Hello friends, this is tutorial for predictive analytics using Python. Now here we are seeing dealing with class imbalance. Okay, now what is class imbalance? A classifier is only as good as the data that's used for training. One of the most common problems we face in the real world is the quality of data. For a classifier to perform well, it needs to see equal number of points for each class. But when we collect data in the real world, it's not always possible to ensure that each class has exact number of data points. If one class has 10 times the number of data points of another class, then the classifier tend to get biased towards the first class. Hence, we need to make sure that we account for this imbalance algorithmically. So let's see how to do that. Okay, let's see the program for class imbalance. How we will account for class imbalance, we will see in this program. So first you have to import few packages that this is your numpy package, this is your matplotlib package and then your sklearn package, that is your scikit-learn package. Next we are importing utilities class, in which we have defined our visualize classifier function, which we have seen in our previous tutorials. So you know what this function is actually for. Now your first step is to load input data. So we are loading data from this file. This is your data imbalance.txt. It's containing data in the form of comma separated values. So we are using delimiter equals to comma, and we are using load.txt function of numpy package for loading data, and then again we are applying slicing operation for getting data in x and y variable. Next, we have to separate our input data into two classes based on labels. So we are using y as a label and getting data from x, and we are getting data in class 0 and class 1. Next, we are visualizing our data using scatter function, and PLT is your actually denoting pyplot package of matplotlib. So again, we are using our marker equal to x and marker equal to o for class 0 and class 1 respectively, and we are giving it as a title input data. Next, we are splitting our data into training and testing data sets. So we are using cross validation package of sklearn and train test split function of that package. Here we are using test size, this is your size of testing samples, and random state, that is your random data generator. Next, here we are using extremely random forest classifier. So for that we will use extra trees classifier function. Now we are passing parameters in that function. So these parameters are n estimators, max depth, and random state. So n estimators is your maximum number of trees in that random forest, and max depth is your height of tree, and random state, that is your random data generator. Now we are passing input parameter during running that program, that is your balance. So this balance is controlling whether or not we want to algorithmically account for class imbalance. So we are adding class weight. This is extra parameter, class weight balanced. So if we are passing balance as our input parameter, then we are adding one more parameter to this params variable. So this is your class weight, and then we are passing that parameter into our extra trees classifier function. So this will be your classifier, and then we are using visualize classifier function for visualizing the classifier using training data, and then we are using visualize classifier function for test dataset. Okay, next we are again evaluating our classifier performance using classification report function, and similarly we are passing 4 parameters in that function. Okay, and then we're using show function of pyplot package. So this was your program, and the basic difference is that we have used here balance parameter, and if we are passing balance parameter, then we are accounting for class imbalance. That is, we are using extra parameter, that is your class weight, for class imbalance. So let's run that program, and after running you will get something like this. Let's see this. This is your input data plot, So we have used marker X and marker O for class 0 and class 1 respectively. Then this is your training data set and this is your test data set. Now let's see this black portion. This black portion is indicating your boundary. Now this is not actually showing the boundary between class 0 and class 1 data. This is due to class imbalance. So if we account for the class imbalance, then see what will happen. First see the classification report. Here see this one on test dataset. Here is showing 0.00. This means that there is a class imbalance problem in that. So now let's see this. If we are passing parameter balance, if we have to use that statement Python, then your file name and then balance. If we are using that statement for running that program, then we will get output like this. In this, the black portion is showing the boundary and it is actually showing the boundary between class 0 and class 1 data. See this boundary and see this boundary. So this is because we are passing balance parameter. So this is your class imbalance controlling. Okay. Now see this classification report. Now here it is not 0, 0. So by accounting for the class imbalance, we were able to classify the data points in class 0 with non-zero accuracy. This is your non-zero accuracy. So this was your difference between this one and this one. Okay. So thank you.